welcome to another video tutorial from Biswa's Coaching, and my name is Vishwanath Chaudhary, and today I'm going to discuss about the facultative heterochromatin and its very important example. Okay, so you know this facultative heterochromatin is dynamic in nature and it is also genic region. So you cannot say that facultative heterochromatin is the non-genic part. Okay, so facultative is dynamic. Dynamic means sometimes it acts as heterochromatin, sometimes it acts as euchromatin based on the situations of the body. Also, you need to remember this is non-genic, non-hereditary. Non-hereditary. What does that mean? That means you cannot get this heterochromatic region from your parents. Okay? During early embryogenesis, there is some cellular programs which actually decide which part will become heterochromatic, which part will become euchromatic and which part will become facultative heterochromatic. Okay. But if I consider constitutive, they are static. This constitutive, they are static and hereditary. Why they are hereditary? Because this is static part of the chromosome. So it will pass from your father and mother to your body. It cannot be changed. Okay. But it can be changed during early embryogenesis. And one example of this facultative heterochromatin that is very important is the X chromosome inactivation in female. X chromosome inactivation in female. Just say your mother and your father. You can get one X from your mother and one Y from your father. And your sister will get one X from mother and another X from father. Okay. Before discussing this thing, you need to remember another thing, that X chromosome is gene-rich region. If I consider this is the X chromosome, there are many genes present in X chromosome. Some of them are sex determining or sex determining region. And if I consider Y chromosome, this is Y chromosome, this is actually very less genic. Less genic region. This is more genic. One important gene present in Y chromosome that is called SRY gene. SRY. SRY gene. SRY means sex determining region of Y. Region of Y. Or SRY. So because of this SRY gene, we are male. It will provide the maleness of our body. Okay. By producing testes and all. But as you can see, for any gene we get two copies in the allelic form. But if I consider only X chromosome, there is no such homologous chromosome of X present in male body. So they are getting one copy of that gene. But if I consider female is getting two copies of that gene. Two copies of that gene. So they are getting two alleles. But we are getting one allele. So if I consider the dose of that gene, male getting only one dose, female getting two doses. So that is why, to compensate the dose from the somatic cells, after the zygote formation, they start mitotic division. to produce our somatic body cells. So during this early embryogenesis, the dose needs to be compensated from female body. So one X needs to get inactivated so that we are getting one dose, also the female also get one dose of that gene. So any one of the X chromosome of these two homologous chromosomes will get inactivated from the somatic cells of female body. That is called X chromosome inactivation or called dosage compensation. That is called X chromosome inactivation or dosage compensation. Okay. So this is two X chromosome, another X chromosome. One of them, any one of them, which one will become the inactive chromosome, you cannot determine. Any one of them can behave like inactive chromosome. So this is random process. So any one of them will become inactive. That means, inactive means it behaves like heterochromatin. Entire chromosome will behave like heterochromatin, but also you can see there are many genes, but no genes from this inactive chromosome will get expressed. This is one example of facultative heterochromatin. Because how can you see this thing in the interface chromosome? By seeing some dark region of X chromosome, not towards the periphery, but somewhere in the middle of the nucleoplasm. And if you want to see this during a metaphase chromosomal state of the chromosome, then you can see some drumstick-like structure, dark drumstick-like structure. Okay, this is also called bar border. Okay, I think this is clear to you. And this X chromosomal inactivation thing was postulated by the scientist Leon. That is why it is called Leon hypothesis. Leon's hypothesis. Okay, I think it's clear to you. So that's enough for today's class. So if you like this video, please hit the like button and don't forget to subscribe my channel and share this thing with your friends as colleagues. Okay, so thank you. Thanks for watching.